For compound interest, the question I had when I was learning about this is, well, how much of an effect does it really have if you compound, once per year or once per day? How much more money do you get? So let's go ahead and calculate those changes here. So we'll go ahead and set up the formulas. So we have our P naught. We're going to start with 100 currency in the bank, 100 units of money. And we're going to have an interest rate of 5%. That's pretty good. And so for n equals 1, right, we're going to have 100 times 1 plus 0.05, and if I really want to follow the formula, it's over n to the nth power. All right, so for n equals 12, let's go ahead and set that up. So that's 100 times 1 plus 0.05 over 12, so this is monthly, to the 12th power. Then if I have daily, it's 100, and I got 1 plus 0.05 over 365 to the 365th power. So how much more money do you really get between these? Well, so I've already calculated these elsewhere. I can do this one in my head. This one ends up being 105. So you started with 100 in your bank account, and you ended up with $5 more at the end of the year, the 5% interest rate, and it was one compound at the end, yearly compounding. Okay, well, monthly, that's got to be better, right? So if you calculate this, it comes out as approximately 105, not looking so good, 0.11. I included the 6 here, that's past usually the number that people keep. Hopefully your bank would round that up, but it's not a whole lot different. This is 105, this is 105.116. Not a whole lot more money, even when you compound it monthly. Well, maybe it'll go up. What about daily? Well, if you do daily, that one isn't much better either. It's $105, and then 0.12, and then 6, and it's dot 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 here. This number ends up being endless. Something. So it's really not that good, but this is going to lead into an interesting thing that some mathematicians came up with.